Good day, everyone. I'm here to explain the working principle of the PCRD machine and relative to the existing diesel engine principles, how it works. Okay, so basically we are going to illustrate the diesel engine, then we can now also look at it one-on-one with the hydraulic powered engine. So now if you look at this diesel engine, the primary source of power, according to scientists, okay, we were told that primary source of power to any mechanical engine is the petrol, the diesel, or the gas, as said in physics and engineering world. But for me as an inventor, I am here to say that the primary source of power as an inventor, not as an engineer, is the battery. Okay, because at this time that this engine is quiet, everything is dead. Okay, nothing is working. The fuel cannot turn on this engine. So we need a first initial power that will energize the system. So that is where the battery, starts up the whole process. So the first source of power to energize this engine is the battery. So the battery brings out the first primary source of power to energize the engine. And when the engine is now energized, as soon as it gains its momentum, it will start relying on the diesel, okay, that will now enable it to cut off the primary source, which is the battery. So at this point, when the battery is now cut off, now the diesel now begins to remain the primary source. Because at that point, the source of power will be remaining on the diesel. So, and why does it work in that way? Because the diesel is meant to have a kind of a flow system that has been energized by the battery. So the liquid comes from the diesel tank and comes to the engine, energizes the engine, creates what is called the PSI, pressure per square inch, that will enable the engine to generate its own force. That force that is generated is what is turning the crank, and the crank is turning the alternator to a certain speed, or which is called RPM, that will enable the alternator to generate its own power. So basically, that is how the diesel engine is designed. And why this engine is going to be operational? In the process, it will start generating heat because of the pressure that is being produced in the engine block. So for that heat to be controlled, they have a cooling system. So the job of the cooling system is to keep the engine heat level in a minimal level, that it will not burn the top gasket or any of the seals that is in the mechanical component of this diesel engine. So that is the job of the cooling system. So that's why you have the cooling system. All of this I have just explained here is all in my hydraulic powered engine. Yeah. Okay, so at this point I want to speak about the difference between the diesel engine and the PCRD machine. So what makes ours different is when the diesel engine generates its power from the engine to the alternator, you take the power from the control panel. The control panel now takes the power directly from the alternator to the load. Now, the difference between the PCRD machine and the diesel engine is that we don't take our power from the alternator, which is also known as the generator, to the load. So ours goes to a step up, which takes the power either to the transmission line, which is known as the national grid, or to another transformer that will step it down, so that the energy can be transported to any distance. Because the type of energy we generate is a massive energy, because we generate from 1 megawatt up to 10,000 megawatts. So whatever we generate, we try to make our evacuation, which is using a transformer, to distribute the power, before it goes to the load. So our power system is designed in such a way that you don't take energy from the generator to the load. We have to put it on a transformer before it goes to the load. So transformer is used for elimination of inductions, as long as it's not overloaded. As soon as you overload the transformer, it will bring back the induction into the system. But if you are working on the average capacities of the transformer, you will eliminate some certain levels of induction. So hence we step it up and we bring it down, so that it will help to eliminate the induction on the generator. So the generator will always get a strong induction when the transformer is overloaded. And we have a cutout fuse to control all of that. So it will get to a certain state whereby you are overloading or you are about to overload your transformer, then the cutout will cut off. So it is designed in such a way that all of this will be programmed so as to eliminate the induction that will definitely come as a feedback to the transformer that will give a signal to the generator, so that our system will have efficiency, because everything about power is all about efficiency. So in your design, whatever you are doing, if you do not consider efficiency in your system, then you have a challenge of having feedbacks that will actually give you shutdowns. So basically, that is the essence of we having the transformer in our system. One, like I said, is for transportation to a long distance, and also to feed it to the national grid, because they have a certain kind of requirements. Number one, your frequency mustn't be more than 50 Hz. So for you to have your 50 Hz, your frequency must not exceed a certain number of speed, so that you don't have higher frequency or lower frequency. So it must be within that. If you're using a 4-pole generator, you must maintain 1,500 RPM, so that you continue to have that frequency, so that you don't keep having. Though in our system we have a governor that controls the speed as to maintain our frequency. So we having the transformer is also to enable us feed into the national grid with the right frequency that is needed, so that it will synchronize with the existing infrastructure. Then we also having the transformer is for transportation of this power to a longer distance where it will be needed, so as to avoid eddy current losses or copper current losses or heat losses and all of that. So whichever losses that is to be encountered in the process, the transformer has a way of eliminating some of those losses. So that is why we take it up on a very higher voltage, so that it can actually go very far. Okay, so that is for the transformer. Then thirdly, the transformer is also used to help eliminate induction. Like I said, the more you lift, the more you increase the voltage, you are eliminating the amps. So the amps is what actually causes induction. So when that is done, you are eliminating. But when you are bringing it down on the step down, you are now building up back the amps. So at that point, as long as you are not overloading the step down transformer, the step up transformer and the generator will never have any kind of induction. So it helps in these three ways. So basically, that is the importance and the reason for our step up and step down transformer. Thank you very much. So I'm going to take you guys in to see how my hydraulic power engine is energized, transmits its power and generates its own power. But for me, I am saying that in this diesel engine, the primary source of power is this battery. Now, because this battery is the primary source of power, the engine does not depend on the battery. So the moment the engine now gains its own momentum, the power is shut down from this battery, and the engine gains its momentum to keep running on the diesel that is coming to the engine. So that is why I said first primary power is the battery, then the secondary primary power is the diesel. But when the battery is cut off, the diesel now remains or becomes the primary source, because that is now what the engine will be depending on. So when we now get to the hydraulic power station, I will be able to explain to you guys the similarities of how they work hand in hand. Okay, so this system that is here will now become my PCRD primary source, which is like the battery. So this system here, this machine here, is what energizes my machine so that it will gain its momentum. And as soon as my machine gains its momentum, it doesn't depend on this primary source, which is like the battery. Okay, so my machine, you can start it with a battery, you can start it with a generator like this, you can even start it with NEPA or PCN or ESCOM, because I'm from South Africa. So in South Africa, PCN is known as ESCOM or NEPA in Nigeria. So basically, that is just what I needed to explain here, so that we understand the primary source or the first initial source of power. Then before you now go to the secondary force that will eventually turn to like a primary source, because as at the time the engine is energized, the diesel becomes its primary source, because the engine will be depending on the diesel. Thank you so much for this. So we are going to do that of the hydraulic, the PCRD. Then you will now see this comparison and how they correlate to each other. Thank you so much.